Thank you very much, sir. Thank you very much. Our next speaker is Muhammad Sarmed. He is from Department of Irrigation and Drainage, University of Agriculture, Tasawar. Mr. Sarmed will talk about the impact of ice melt on hydrological simulation of Upper Indus Basin. Mr. Sarmed, please.
Assalamu alaikum. I am Muhammad Tasawar. My topic is impact of ice melt on hydrological simulation of Upper Indus Basin. Here is the introduction. The Indus River supplies water to 65% of Pakistan's power plants. It is necessary to research the discharge catchment variation in water flow and water resources as a result of changes in climate and environment, as well as their influence on the hydrological state of the upper Indus Basin in Pakistan's northern territories. The approach is used to anticipate and simulate how a catchment responds to rainfall hydrological modeling, which has been used for decades. The Hydrology Engineering Center's Hydrologic Modeling System HMS is a type of watershed model that supports both distributed and lumped models being used to simulate rainfall runoff correlations. It is becoming a very popular and reliable hydrological model because it can simulate rainfall runoff correlation in a short amount of time, is simple to use, and can use common methods. Objective of this research were to estimate the corresponding glacier contribution to the total flow and impact assessment of snow melt on it. Second objective is to evaluate the possible changes in water accessibility and extreme events in water table in the upcoming decades. Here is study area. In this study, data of Swat River was used for the calculation of snow melt and its impact on hydrological simulations. Data collection. Keeping in view the requirements of the present study, data from multiple sources in different formats was collected and used for analysis as per the need of the study. List of the following data sets were used to estimate different parameters of models. Daily rainfall data was of different stations of Swat River like Amandra, Balakot, Tir, Drosh, Klam, Saidu Sharif, Malakant, and daily flow. We use daily flow from Munda Dam, and Landsat data was different Landsats DSMW like this one, and the methodology of this research is a hydrological modeling approach for the calculations for snowmelt and its impact on hydrological simulations. ArcGIS tool with HEC-GeoHMS extensions was used to find the characteristics of study area. All amount of rainfall is not converted into runoff because many losses are occurred like infiltration and evaporation, and remaining amount of precipitation is transformed into runoff. The losses during the rainfall event were calculated by using the initial and constant loss method. The time of concentration was calculated with the help of SCS lag equation, and for this lag time is calculated initially as follow. TL is equal to 0.00227 L power 0.8 100 over Cn power 0.7 multiplied by slope s की power minus 0.5. Here Cn is a curve number value, TL lag time in hours, slope s, and L is main stream length in meters, TC time of concentration in hours. Next is the initial values of storage coefficient were computed from empirical relation proposed by Russell as below. R is equal to C multiplied by TC. Here C is proportionality coefficient. The values changes for different areas. Its value is 1.1 to 2.1 for urban areas. I'm sorry for interrupting. For snow water equivalent, the following equation is used. Snow water equivalent is equal to SD rho S over rho W. SD is snow depth, rho S density of snow, rho W density of water. Next are the results. The period we use data from 1st April to 31 March 2000 has been given on the x-axis, while the flow is given on the y-axis in cumex. Here the blue line indicates the observed flow during the duration, while the red line indicates the optimized flow. Parameters being optimized by the model itself by iterations, thus producing this line. The green line shows the snow contribution in the line. Next is the scatter plot for the optimized flow has been given in figure. Regression equation was developed for the Swat River catchment with an R2 value. R2 value is 0.6509. This one is the correction factor. Here is the conclusion. In this study, the HMS model was used to predict runoff hydrographs in the upper Indus Basin watershed in Pakistan's north. For the modeling rainfall runoff processes in the upper Indus Basin watershed, it may be advantageous to adopt the HMS. The above mentioned approach is useful in reducing the amount of time and money spent in gathering runoff data. Furthermore, the modeling of runoff in an ungauged watershed when no gauged stations are available can be valuable, and the model can be used afterward to regulate production and cultivate goals. Thank you very much.
Thank you very much for your presentation.